So if you want to have a less aggressive or a less restrictive caching strategy, then you might want to write your own middleware and add your own cache headers into that middleware. I'll provide an example starter middleware in the lesson notes as a starting point for the interested, and I'll leave it as an exercise to you to enhance that middleware based on your needs. Now let's focus our attention to this session middleware. Since this is an in-memory session, if our application crashes for any reason, we'll lose all of our session data. And also if you have more than one server behind a load balancer, and if you use an in-memory session store, then you'll have what's called a session affinity problem. To give you a concrete example to demonstrate it, let's say that we have two node apps behind a load balancer, and the user makes a login request and registers a session in the memory of the first app, and then the same user wants to get her account details and sends an account request to the load balancer again. However, this time the load balancer routes the request to the second app. Since this second app does not have the session info in its memory, it will return an HTTP 400 bad request to the client, which is not something that the client is expecting to see. So how can we solve this? If our load balancer has a session stickiness feature, we can configure the load balancer to route all the requests that have a certain session cookie back to the server that initially created that session and assigned that session cookie to the request. This way, for the duration of its session, our user will be talking to only a single server, no matter how many requests she sends. Although this sounds like a solution, it has certain disadvantages. For one, sticky sessions also make it more difficult to keep the servers in balance, so our load balancing will be disproportionate at best. Why? Because a server can become overloaded if it accumulates too many sessions, or if specific sticky sessions require a higher number of resources, and also if a server is overwhelmed because it has a high load. This could result in your load balancer having to shift the client requests to a different server mid-session, which will result in data loss. Additionally, if you bring a new server online, your load balancer will not distribute the existing load to the new server. So if you have a dynamic load balancing system to deal with traffic spikes, using sticky sessions will slow your ability to respond to a quick spike in traffic. And further, for whatever reasons, if a single user's traffic swamps a certain server, then all the users on that server will be impacted, and there is no way to move the other users' traffic to the less busy servers during the lifetime of their sessions. So in a highly dynamic system or in a microservice application, using sticky sessions is almost always a bad idea. So what can we do instead? One option is to move the session state to an external session store, such as Redis, and let all the servers connect to that store. This way, even if a server goes down, the user will not lose her precious session info, and she can continue her session without interruption by talking to the other servers behind the load balancer. By using an external session store, since you don't have to stick users to servers, you'll have a more evenly distributed server load. In our case, we'll use Redis as an external persistent session store, and to use it, first we'll require connect Redis